Hi everyone, thank you very much for your hard work during the remote assessment. It was great to see everyone trying their best, and I could see some great work being done, a lot of answers being answered correctly. So I will now go over all the questions from the remote assessment. I'm going to start off with part 1, of course. So let's see if I can write. Okay, I can, that's great. Sorry. Okay, there are 60 people in a choir. Half the people are women. So, you know what, I'm just going to write now 30 women. The number of women in the choir is 3 times the number of men. So that's something I should underline. 3 times. Let me get rid of this. The rest of the people in the choir are children. Okay, and they've actually got this here as well. Women, here, men, and children. So there are 30 women, we know that already. Men, how many men are there? So there's 3 times as many women as there are men. So 30 divided by, sorry, it's not very clear. 3 equals 10. And so we have 40 people, the rest of them are children. So 20 of them are children. Then here there's a ratio, which is the number of children to the number of men is represented by the ratio n to 1. So the ratio is 20 to 10. If you simplify this ratio, we get 2 to 1. And so our answer is 2. As you can see, I have 4 marks for this question. So moving on to question 3. Work out, so you have to multiply these 2 mixed numbers together, give your answer as a mixed number. So I will convert them into improper fractions. So this becomes, so 4 times 1 is 4, 4 plus 3 is 7, so 7 over 4, multiplied by 1 and 3 multiplied together is 3, 3 plus 1 is 4 over 3. Now I could multiply 7 and 4 and write 28 over 12 and then simplify, but I'm gonna do it slightly differently, as you can see here, slightly shorter way in my opinion. I have a 4 here and a 4 here, so these will cancel, and my answer will be 7 over 3. So when these cancel, you can just replace it with a 1, so essentially it's 7 multiplied by 1 over 1 multiplied by 3. If you were to simplify this fraction, you'd get the same. Divide by 4, 7, divide by 4, 3. So our answer here will be, okay, let me write 7 over 3. Okay, it's not really working properly, but the answer is 7 over 3. The most important thing is we worked it out. So I'm going to move on to question 5. As I said, you don't need to answer questions 1 and 4, and there are a few other questions you don't need to answer, so I'll only do the ones which I've asked you guys to answer. The diagram shows a triangle. ADB is a straight line. The size of angle DCB, so that's this angle here, is in ratio with the size of angle ACD. Where's ACD? So this one. So it's 2 to 1. So I'll just write 2 to 1 here. Work out the size of angle BDC. So I'll write here X. This is the one we want to work out. Okay, so let's see. Work out the angle of BDC. Alright, so triangle ABC, (51 degrees, 75, and this third angle. We can work this out because 180, we know that the three angles will add up to 180. So 180 take away 75 take away 51 equals 126, 454 degrees. Let me just see if that's 126. Yeah, I'm pretty sure that's 54 degrees. Yeah. Okay, so now I know that this whole angle here is 54 degrees. So these two angles need to add up to give us 54. So there are three parts. Which add up to 54. So we're going to do 54 divided by 3, which is 18. Right, so each part is worth 18. And so this angle here is 18. It's not letting me draw here. But anyways, I'll write here. This angle here is 18 degrees. And this angle here is 36 degrees. Now lastly, we need to work out this angle. And so we do 180 take away 51 take away 36, which is 180 take away 87, and so that gives us 93 degrees. So let's see if that works. Yeah, we get 4 marks. Question 6. 4 red bricks have a mean weight of 5 kilograms. 5 blue bricks have a mean weight of 9 kilograms. 1 green brick has a weight of 6 kilograms. Donna says the mean weight of 10 bricks is less than 7 kilograms. Is Donna correct? So I can say yes or no. Sorry. Okay. Let's see. Okay, so what I need to do here is do 4 multiplied by 5 plus 5 multiplied by 9 plus 1 multiplied by 6 and so that would give us 20 plus 45 plus 6, so 65, 71. We have 10 bricks in total. Do we? Yes, we do. So 71 divided by 10 would give us 7.1. So going back to Donna's statement, the mean weight of the 10 bricks is less than 10 kg. I'm going to say no, it is 7.1. Oh, sorry. 7.1. Yes, that's right. Okay, the next question is question 7. So remember here, you have to, because there's a bracket here, this just means p to the 2 multiplied by 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 p to the 2, so that there are 5 different p to the 2's, if that makes sense. And so a quicker way of working out is just doing 2 multiplied by 5. That would be p to the 10. So here I'll write p to the 10. Okay, it's not very good. But look, you got the answer there. It doesn't really matter about what we have in the little answer box. Here I'm gonna write 12x to the 7 y. I'm gonna write it as a fraction. I always think it's easier to write it as a fraction. (12) divided by 6 gives us 2 over 1. X over 7 divided by x over 3 would give us x to the 4. And y cubed over y is y squared. So our final answer is 2x to the 4 y squared. So this is question 7. The next one we're going to do is question 9. A car travels for 18 minutes at an average speed of 72 kilometers per hour. How far will the car travel in these 18 minutes? Okay, so the units here are kilometers per hour, and here the unit for time is minutes. So I'm going to write this in terms of hours. So this is the same as 18 over 60 hours, if that makes sense. It's obviously less than an hour, right? So it's a fraction which is less than 1. How far will the car travel in these? So we need to use our knowledge of speed equals distance over time. So speed equals distance over time. What we have, we need to work out the distance, right? So speed multiplied by time equals distance. 72 multiplied by our time would give us the distance. Let me just use a calculator for that. (21.6) is what I got. So let's see if that's correct. Yes, it is. David says 72 kilometers per hour is faster than 20 meters per second. Okay, so let's see if David is correct. 72 kilometers. So right here, 72,000 meters. How many seconds are there in an hour? So in an hour there are 60 minutes. Multiplied in each minute there are 60 seconds. So multiplied by 60 again. So that's 3600. So alright, 3600. So saying 72 kilometers per hour is the same as 72,000 meters per 3,600 seconds. And so if you divide this by, oops, don't know why I did that. If you divide this by 3,600, you have to do the same thing to the 72,000. So 72,000 divided by 3,600 is 20. So we have 1 mark. Now here it says 72 kilometers per hour, 20 meters per second. So as you can see, it's the same. 20 meters per second here is the same as 72,000 meters per 3,600 seconds. So here I'm going to write the equal sign. Huh? Is David correct? No. I will put equal sign here. Yeah, look, we got the 4 marks for that as well. Let me see what question is next. Okay, 11 is the next one. Moving on to question 11. So there are P counters in a bag. 12 of them are yellow. Shafiq takes at random 30 counters from the bag. 5 of these 30 counters are yellow. So we need to work out an estimate for the value of P. Sorry, let me get rid of this. Now, if you look at these, if you compare these sentences, they look very similar, right? There are P counters in a bag. Shafiq takes 30 counters. 12 of the counters are yellow. 5 of the counters are yellow. So there are some similarities between these two. And the fact that it asks for an estimate, that's another clue that, well, it seems that this is a sample. This is a sample. And so what we would need to do is write the fraction of yellow. The fraction of yellow counters in the sample is 5 over 30. And the actual fraction of yellow counters over the total is 12 over P. Now we need to work out what P is, but of course it's going to be an estimate because we have a sample and it doesn't necessarily represent the whole population. So we have 1 over 6 equals 12 over P. And so if you cross multiply, we get P equals 12 multiplied by 6, which is 72. So let me try 72. Yes, we get the answers. Question 14 is next. question 14. Now, I'm pretty sure we've seen this question before in class, actually. A problem-solving question involving the area of a triangle. So let's use our knowledge of the area of a triangle. We know that the area of a triangle is equal to half multiplied by base times height. So base is x plus 4. Height is x take away 2 equals 27.5. So I'm going to now multiply both sides by 2, so we get rid of this half. .5 multiplied by 2 is 55. Now we're going to expand brackets, so x squared plus 2x take away 8. Subtract 55 from both sides and we get x squared plus 2x take away 63 equals 0. So now I am going to factorize. So two numbers which multiply to give us negative 63 and add to give us 2. I'm thinking 9 and 7. The 9 and the 7 has to be negative. So x equals negative 9 or x equals 7. But of course, since x is a length of a triangle, cannot be negative. So I'll cross this out. X equals 7. And so seven take away 2 is 5. 7 plus 4 is 11. Work out the length of the shortest side of a triangle. Let's try 5. Here we have a recurring decimals question. So I'll write x equals 0.418 recurring. 10x is 4.18 recurring. Just keep that on top. Yeah. And 100, actually let's do 1,000. 1000x is 418.18 recurring. So now let's do 1000x take away 10x, and the reason why I'm taking away these values is I want these recurring decimals to cancel out with one another. So 418.18 recurring take away 4.18 recurring gives us 414. And our left hand side, I forgot to do that, is 990x. So if we make x the subject, we need to divide both sides by 990. So our answer is 414 over 990. Okay, so A and B are too similar. So I'll underline that. similar cylindrical containers. So we know that this question is going to be linked to similarity, the similarity topic, and we can see two 3D shapes as well. So not just are we going to be using our knowledge of similarity, but we will also be thinking about linear scale factor, area scale factor, and volume scale factor. So they've given us a ratio which is linked to the area scale factor. And, sorry, let me get rid of this. Yeah. And it says 4 to 9, and I already can spot that these two are square numbers. 2 squared, 3 squared. So just bear that in mind. Tyler fills container A with water. She then pours all the water into container B. Tyler repeats this and stops when container B is full of water. So, as you guys know, the space within a 3D shape is the volume. And so here we're using the volume of container A to fill water into container B. So we're going to be seeing how much bigger, by what scale factor is volume B larger than volume A. Work out the number of times Tyler has to fill the container. Okay, cool. So if this is our ratio which represents the area, I'm going to write the ratio up here which represents the volume. So it's going to be 2 cubed to 3 cubed. So let's say the volume of container A is 8 centimeters cubed, for example. The volume of container B will be 27 centimeters cubed. So now we need to assume, let's just assume that these are the actual volumes. We're going to do 27 divided by 8, which is 3 point, let me use the keyboard, so it's 3.375. So we need to fill the container, sorry, let me just get rid of this. So work out the number of times that Tyler fills container A with water. So we've worked it out as 3.375 times. But of course, in these types of questions, we round up to the nearest integer because you can't fill a container 3.375 times. You only fill it in integer, going up in integer values. So I'll write a 4 here, and as you can see, that gives us 4 marks. For question 19, we have a very common indices question. So we need to rewrite these 3 powers so that they have the same base. When they have the same base, then we can multiply or divide them. So I'm going to write 3 squared to the power of -1/2 equals 3 cubed to the power of 1/4 divided by 3x plus 1. So now we will expand the brackets. 2 multiplied by -1/2 is -1. 3 multiplied by 1/4, 3/4, divided by 3x plus 1. Now we have an equation, and our aim is to solve the equation, work out where x is. We have the same base here. These three powers have the same base. So I can write -1 equals 3/4 . Remember, when you divide one power with another, divide one power by another, then you need to subtract the indices. So here we need to do 3/4 subtract x plus 1. Now we need to solve for x. So I'm going to plus x plus 1 on both sides. So x plus 1, take away 1, they will cancel out. And so now we just have x equals 3/4. So let me type 3/4. It's fine, I know I'm correct. Part 2 of the remote assessment was a lot more difficult, so I'm going to go through the solutions and I'm going to talk about some of the ideas we discussed when we were back in school a few months ago. Topic recognition, highlighting and making a note of all the key information. So, and of course the reason why we do that is to simplify the question. As you can see, there is a lot of information in each question, but let's start off with this one. The image shows a pyramid with square base ABCD. So to be fair, I could start now. Pyramid, square base ABCD. The base of a pyramid has a side length of 6 centimeters. So given that the base is a square, I can now say that this is 6, this is 6, 6, and this one here is 6 as well, 6 centimeters. The point E is 10 centimeters vertically above the midpoint of AC. So what they're telling us now is the height is 10 centimeters. Calculate the size of angle EAC. So underline EAC. So EAC means we start at E. So I'll draw a dotted line. Come to A. So that has to be this angle here. So what I have to do is work out the angle here. Now we can see we have a right angle, a few right angle triangles within this pyramid. So we know we're going to have to use, in terms of topic recognition, we're going to be using trig and Pythagoras. And it's a 3D shape, of course. So I'll write 3D in brackets. Alright, what I'm going to do is draw this right angle triangle again here. And we need to work out this angle. So I'll label it as well. E, A, and this is the midpoint of A and C. So I'll just call it M for now. The height is 10. The base is, we need to work that out. And the hypotenuse, we don't know it. So how would we work out this let's use orange. Yeah. Well, this base is a square, right? So we're going to use Pythagoras' theorem and then divide work out the hypotenuse and then divide it by 2. So we have 6 squared plus 6 squared, which equals 36 plus 36, 72. So the hypotenuse is root 72. And so this bit here is root 72 over 2. So root 72 over 2. I mean, you could use a calculator, but I don't have one with me right now. Alright, root 72 over 4, which equals 8, I'm thinking 18, is it 18? 2, 3, yes, it's 18. Of course, root 18. So this is root 18. And now we can use trig to work out this angle here. So let's label the triangles. Opposite, adjacent, hypotenuse. We don't have a hypotenuse, so we need to use, in terms of SOHCAHTOA, we need to use TOA, so tan angle equals 10 over root 18. So theta equals the inverse of tan, 10 over root 18. Let me just work that out using my computer. We need to round to do 2 decimal places. So the value I have got is 67.010232 degrees. But because we only need to give the value to 2 decimal places, I am going to write 67.01 degrees. Moving on to question 2, the diagram shows a solid shape formed from a cone on top of a hemisphere. The height of the shape is 13 centimeters, and they've actually written it for us already. The base of the cone has a diameter of 10 centimeters. The volume of the shape is A pi centimeters cubed. Work out the value of A. So they have given us the volume of a sphere. That's useful. What is the volume of a cone? So the volume of a cone is volume of a cone equals pi r squared h, all divided by 3. It's similar to the volume of a cylinder, but divided by 3. So now we're going to use these 2 formulae and the values we have. So the total volume of this 3D shape will be volume of cone plus volume of sphere volume of cone is pi r squared, so the r is 5. So I'll write multiplied by 25, multiplied by the height, which is, so if this is the radius, the height of just the cone will be 13 take away 5, so 8 centimeters. So I'll write 8 over 3 plus volume of a sphere, so 4 over 3 pi r cubed, so 5 cubed, which is 125. But this is a hemisphere, so we need to divide all of that by 2. So I'll just write divided by, change this to a 6. Now we've divided it by 2. Okay, so now let's work this out. 200 pi over 3 plus 4 multiplied by 125 is 250, 500 pi over 6. So now we're just adding the two fractions together. So we have, let's say 400 pi over 6 plus 500 pi over 6 equals 900 pi. Now we simplify, and so 900 divided by 6 is 150 pi. Units are centimeters cubed. And so going back to our question, we could say, let me move this out of the way. Going back to our question, we could say A equals 150. Question 3, we have done this question so many times in class. Ratio, and I actually think one of my TikTok videos are on this type of question as well. X squared to 11x take away 2 is equal to 1 to 5 as a ratio. So this means x squared over 11x take away 2 equals 1 over 5. And you could also say 11x take away 2 over x squared equals 5 over 1. It doesn't really matter which one you opt for, so I'll just rub out this one. Now we are going to cross multiply. So we get 5x squared equals 11x multiplied by 2. Move everything to one side. 11x plus 2 equals 0. Now we will have to use quadratic formula. Using the quadratic formula, we have negative b, which is 11, plus or minus root b squared is 121. Take away 4ac, so that's 4 multiplied by 5 multiplied by 2, so that would give us 40. Over 2a, so that's 2 times 5, so 10. So this equals 11 plus or minus root 81. So that's nice, we don't really need to use a calculator for this. So we have 11 plus or minus 9 over 10. So our two values will be 11 plus 9 over 10, which is 20 over 10, which is 2, or 11 take away 9 over 10, which is 2 over 10, which is 0.2. So our answer is just 2 or 0.2. Question 4. A, B, C, and D are points on the circumference of a circle. AD is the same as BC. Prove that triangle AED is congruent to triangle BEC. Provide the reason for each stage of your proof. So, this angle here and this angle here are the same. So angle AED equals angle BEC because they are vertically opposite angles. Opposite angles. Well, we already know that AD is the same as BC. Now, this is the hardest question in part 2 in my opinion because we haven't actually learned about circle theorems. So whilst you have seen some questions, I don't really expect you to be able to answer this question. But I'll still go through the answer anyways. This angle here is the same as this angle here. And this angle here is the same as this angle here. So I can write angle DAE equals angle CBE. Angles on chord are equal. This is the chord I'm talking about. ADE BCE. Same reason as above. And here I'm talking about this chord. And so finally, we need to remember it's a congruency question. So the condition I will use here is angle, side, angle. So I will say triangle AED is congruent to triangle BEC by angle side angle. Question 5. A is inversely proportional to B. So we already know what the topic is, it's inverse proportion. And look, there's another one. B is inversely proportional to C. So I'll write here B equals inversely proportional to C. I'll write here K2 because it's a different constant. It's a whole new equation, so we have to write a different constant. So here we have two constants of proportionality and they might have different values. Let's see, using these figures here, what the values of our two constants are. So 3.2 equals K1 over B is 5. So K1 is 5 multiplied by 3.2, which is 16. So we can say A equals 16 over B. Here we have 5 equals K2 over 0.8. 5 multiplied by 0.8 is 4. 4 equals K2. And so B equals 4 over C. Now we need to write the formula for A in terms of C. So essentially I want to substitute this into here instead of this B. So I'll write here A equals 16 over the fraction which is equivalent to B is 4 over C. So we have A equals 16 divided by 4 over C, which is 16 multiplied by C over 4, which is A equals 4C. So now we have a formula in terms of C. Here we have a similar question to one of the questions from the first part of a remote assessment. The diagram shows a right angle triangle. All the measurements are in centimeters. The area is 96 centimeters squared. Calculate the perimeter. So that's different to the previous question. So to calculate the perimeter, we need to work out this length here, so the length of the hypotenuse. So we will be using Pythagoras' theorem. However, we first need to work out the value of x. So 2x take away 2 multiplied by 3x minus 5 multiplied by a half equals 96. So 2x take away 2. Multiply 2 to both sides. We get 208. Expand brackets. 6x squared take away 6x, take away 10x, so take away 16x plus 10 equals 192. 6x squared, take away 16x, 182. So that's divide by 2. We get 3x squared, take away 8x, take away 91 equals 0. Now we are going to use the quadratic formula to work out where x is. So here is where I have gotten up to. Root 1156 is 34. So our two answers will be either 42 over 6 or 26 over 6. Negative 26 over 6. I already know that it cannot be negative, and so our answer, our x value, will be 42 over 6, which is 7. So now we need to work out the hypotenuse. Which, by using a calculator, we get 20. So hypotenuse equals 20. Lastly, we need to calculate the perimeter of this triangle. So 12 plus 16 is 28, plus 20 is 48. Question 7. Ishmael has red and blue counters in a bag. The ratio of red counters to blue counters is 2 to 3. He then adds 20 blue counters to the bag. The ratio becomes 3 to 7. So initially we have a ratio of 2 to 3. So we have 2x, so 2 parts, each part is worth x, and 3 parts. Now the value of each part changes, so I'm going to use a letter. We have 3 parts now, and we have 7 parts. What is happening from here to here? We are adding 20 blue counters. What is happening from here to here? Well, nothing. We're not actually changing the color of red counters. So now I'm going to write, based on what I just said, I can write 2x equals 3y, because the total number of red counters will not change. It will stay the same. However, for my second equation, I'm going to write 3x plus 20, because I'm adding 20 blue counters, and that equals 7y. So I want to work out the number of red counters in a bag. So I have 2 equations. Now I'm going to solve these equations. So let's say this is x equals right. Now I'm going to substitute this bit. I am going to substitute this bit into here. So 9/2y plus 20 equals 7y. 20 equals 7y, take away 9/2. Y is 5/2y. And so one part is 40/8. Yeah. Solving for y would give us y equals 8. Now, I know what 8 is worth. I know what y is worth. It's worth 8. The question asks for how many red counters we have. So 3 multiplied by y gives us the number of red counters. We don't even need to work out the value of x. It's not needed. I'm going to write here 3y equals 3 times 8 equals 24. The nice thing about this question is that there are several ways of working it out. And so if you have another method which you think is probably easier, then please feel free to send it to me and I will share it with the rest of the class. Question 8. X and y are points on a circle and AB is the tangent to the circle at x. So AB is a line which touches the circle at one point. AOY is a straight line. Angle OAX is 38 degrees. It says down the diagram as well. Work out the size of angle YXB. So YXB is here. So we need to work out this angle. Let's make a note of everything we know here. So we know that this is a right angle. Actually, just by doing that, we can work out this angle here, right? So we're going to do that in a sec. Let's just make a note of other things we know. So here to here is the radius. And O to Y is also another radius. So this is actually an isosceles triangle. So let's work out the value of this angle here. So it's 180 take away 90 take away 38, which is 180. I'll just work out 60, 50, 52, 52. So 52 degrees. Using that, we can work out this angle here. Because angles on a straight line add up to 180. So 180 take away 52 degrees equals 140, 30. 128. Yeah. Now we know that these two angles are the same because it's an isosceles triangle. So those two angles, let's see, 180 take away 128 is 52. So 52 divided by 2 is 26. So each of these angles will be 26 degrees. And here we have a right angle. So 90 take away 26 will give us the value of the angle YXB. So that is 64 degrees. Question 9. So a bag contains 5 black counters and at least 2 white counters. Let me just underline the key information. At least 2 white. 2 counters are selected from a bag at random. The probability of selecting 2 counters of the same color is 2 times the probability of selecting 2 counters of different colors. How many white counters are there? So we're going to draw a tree diagram. So there are 2 outcomes, selecting a black counter or selecting a white counter. And on the second selection, there will again be 2 options. Black, white, black, white. So let's use black for black. So 5. There are 5 black counters. If we have selected one, then there will be 4 black counters. We don't know how many white counters there are, so I'll just use the letter W for now. So W. If we have selected a white counter, then on the second selection there will be 5 black counters and there will be W take away 1 white counters. Alright, so the probability of selecting 2 black counters is 5 multiplied, it's 5 over n multiplied by 4 over n, where n is the total number of counters we have. So I'll write 20 over n squared. The probability of selecting a black and then a white counter is 5 over n multiplied by w over n. So 5w over n squared. Probability of white followed by white followed by black is also going to be 5w over n squared. And lastly, selecting white and then selecting white again would give us a probability of w multiplied by w take away 1 over n squared. So the probability of selecting 2 counters of the same color. What is the probability of selecting 2 counters of the same color? Well, we either have 2 black counters or 2 white counters. So we need to add them together. Alright, here, probability same equals, so it's all over n squared, so I might as well take that out. And in brackets, I'll write 20 plus w take away 1 So this is just 20 plus w squared, take away w. Then it says the probability of selecting two counters of the same color is 2 times the probability of selecting two counters of different colors. So this is 2 times the probability of selecting two counters of different colors. So I'll write here different. If this is twice as big in size, then you have to, in terms of setting up an equation, probability that the two counters of different colors multiplied by 2 would give you probability that they are the same color. So now we're going to use this. The probability that the two counters are different colors, well, we can either have black followed by white or white followed by black. So we need to add these together. So if you add them together, you get 10w over n squared equals, multiplied by 2 equals probability that they're the same color. So I'll just write 1 over n squared 20 plus I'm running out of space, so I'll continue in the box here underneath where the answer line is. So we have 20w over n squared equals w squared take away w plus 20 multiply both sides by n squared, and so these two will just go, and now we will rearrange so that we have one quadratic equation. This would be take away 21w plus 20 equals 0. Factorizing now, w take away 20, w take away 1 equals 0. So w is 20 or w is 1. Now, I was wondering when we're going to use this information. We know that we have at least 2 white counters, and so w cannot equal 1. W has to be at least 2. So our answer is w equals 20. There are 20 white counters. Question 10. Line L1 has this equation. So whenever I see an equation in this form, I'm going to rearrange it because it is a lot easier to work with an equation which is in the form y equals mx plus c. So this is going to be 3y equals 6 plus 2x, which is y equals, let's write 2 over 3x plus 2. So now I know my gradient and my y-intercept. It intersects the y-axis at point P. So let's just draw this. It intersects the x-axis at point P. Point Q has coordinates 10, 0. say this is Q. P. Alright, line L2 is perpendicular to line L1 and passes through point Q. Line L2 and 1 intersect at point R. Calculate the area of triangle PQR. Okay, I'm going to draw another line. So L is going to be perpendicular, so that means it has to be a right angle. So something like this. This is point R. Okay, so we know that the coordinates of Q are 10, 0. Let's work out the coordinates of P. So this is when x equals 0. So I'll write y equals 2 over 3 multiplied by 0 plus 2. So y equals 2. Sorry, that is wrong. What I'm doing right now is wrong. I need to set y equals 0. Intersects the x-axis when y equals 0. So I'll write 0 equals 2 over 3 x plus 2. So that's 2 over 3 x equals negative 2. So x equals, multiply both sides by 3 over 2. So that would give us negative 3. Right? Negative 3. So the coordinates of P are negative 3, 0. Okay. Now we need to work out the coordinates of R. So L2 will have a gradient of negative 3 over 2 because it has to be the negative reciprocal of 2 over 3. So I'm going to write y equals negative 3 over 2 x plus c. I'm going to use the fact that it goes through Q. I'm going to use the coordinates of Q to work out the equation of L2. So right here at Q, the y value is 0, the x value is 10, so negative 3 over 2 multiplied by 10 plus c, so we have negative 30 over 2 plus c gives us 0, and so c has to be 30 over 2, positive 30 over 2 of course. 30 divided by 2 is 15. So the equation for L2 is y equals minus 3 over 2 plus 15. Sorry, I forgot the x. Now the point R is the point of intersection between L2 and L1. So that is when L2 is equal to L1. So L1 is 2 over 3x plus 2 equals negative 3 over 2x plus 15. So that's 2 over 3x plus 3 over 2x equals 15, take away 2. Over 6, x equals 13. So x equals 6. So R has an x coordinate of 6. Now if I sub it into either L1 or L2, I can work out the y coordinate. So L1 is y equals 2 over 3x plus 2 sub x. So we get y equals 2 over 3 multiplied by 6 plus 2, which is 12 over 3 plus 2, which is 4 plus 2, which is 6. Okay, so this is 6, 6. Let's draw a triangle again. Actually, forget about that. Let me use a different color. I've used all of them. The height of this triangle is 6. The base of this triangle, it goes from 10 to negative 3, so it's going to be 13. So area of a triangle PQR is 1/2 times 6 times 13, which is 3 multiplied by 13, which is 39 squared units.